Pesticides are necessary to combat mosquitoes in Florida. But as humans continue to modernize methods to control those pests, those methods can cause issues up and down the food chain. That's what Dr. Melissa May and lab assistant Kenzie Pruitt with the Florida Gulf Coast University Water School are discovering on Kimberly's Reef.
So looking into Southwest Florida specifically, obviously mosquitoes are a big deal here. So there's a lot of insecticides that target mosquitoes. And a lot of those active ingredients include something called pyrethroids, which are a synthetic man-made version of a natural compound derived from chrysanthemum flowers actually. So it seems like it would be very natural and organic. However, there's a man-made version of that compound that is actually very toxic to marine species, specifically fish.
And one of the ones we're really interested in is permethrin, which is commonly used as mosquito killer. We have mosquito control that goes around and sprays insecticides, and all of that ends up in the water. Insecticides, and particularly permethrin, can be really toxic for fishes. They don't metabolize it like they do some of the other organic contaminants. And so at really high loads, it can cause mortalities. And so what we're trying to see is, are there pesticides at the reef? Are they getting into fish at the reef? And if it's impacting the physiology of those reef fish.
With Kimberly's Reef about 8 miles from shore, the first question for Kenzie was how pervasive those chemicals could be found in Gulf waters by testing the water.
So she does from the Caloosahatchee River, from Estero Bay, and then from Wiggins Pass, and samples every 2 miles out to Kimberly's Reef. So we can see if there's like a dose effect. So we would expect the pesticides would be higher closer to shore, and as they move further offshore, they get diluted out.
The samples revealed a surprise about where a lot of the pesticides were flowing from.
It seems like they're coming from Wiggins Pass instead of from the Caloosahatchee River. And we did find pesticides at Kimberly's Reef in the water. We haven't quantified it yet, but we were able to detect presence.
So now the next step is to see how fish are uptaking that, and then what that is doing to their physiology.
In the lab, Kenzie gave live fish small doses of pyrethroid permethrin every day for a week. The fish were then terminated to see how the pesticides affected various tissues.
And theoretically, more will be in the gill and the liver. Mostly the gill, if they're being exposed to it through the water, obviously their gills. And then the muscle is more like long-term storage, so if it stays in their body long enough, it'll get worked into that.
Testing for pesticides could have broader impacts in various waterways, especially estuaries like Estero Bay, where juvenile fish live in nurseries.
They could accumulate those pesticides and then move out to the reef as adults, sort of migrating outwards towards the open waters, and take those pesticides there. And then, for instance, a bigger fish could eat that fish, and then it could slowly work its way up into the possible human food web.
Kenzie's research at the water school is ongoing and could help in the future health of Southwest Florida waters.
So I think here we tend to blame everything on the Caloosahatchee and Lake Okeechobee, but there's lots of other impaired waterways that can contribute to pollution. And so her study will help us understand where those are coming from, which could help with management practices.
Major support for Kimberly's Reef is provided by Bo Deal and George Gelman, who believe the human spirit is behind every scientific discovery.